Okay. I also have been working on a theory of unification. And the first thing I found out is that if you're working on unification, you have to have a sense of humor. Because if you're going to try and tell somebody very profound, you can't take it too serious. Now, I'm going to briefly describe what I'm doing. There are a lot of good, interesting attempts at unification out there. I wish, everybody. There are a lot of interesting attempts at unification that I wish got some funding. That got more attention. I'm not saying mine's unique. It's really not mine. But I'm saying it can do one thing that no other theory has done, is that the General Allais Effect is a direct consequence of it. It comes right out. Okay, we're supposed to push something else.
The down arrow. Right.
I'm pushing the down arrow. What do I point at?
Yeah, be close.
Try it on the computer.
Okay.
Double down.
Oh, wait a minute.
Push the up.
That was a double. Okay. I model an electron, that's the particle I start out with, as a spherical rotation, space ether, that's right. And this is a model for unification that's been pursued by both Beatty, Pratt, and Racy, Milo Wolf, who is a member of our alliance, and Tom Bearden, who has been a member on and off. I wish somebody would give the theories of this type more attention. They show a lot of interesting properties. The other thing I'm going to outline briefly is that some people have said that there is a relationship between angular momentum and the mass of an astronomical body. And some people are saying that's due to the non-randomness of the fundamental particles. That if something has a certain angular momentum, you have a net excess of particles with a spin in that direction that cause it. Most of the angular momentum of elementary particles cancels out. But there's some evidence that not all of it does, and this is related to the mass of the particle. Others have said if that is true, you would also get a net magnetic field. And Sarah, Barut, and Gorditz have all shown it comes out just about right, if you make that assumption. That would be the origin of magnetism. You have elementary particles aligned non-randomly. There's a small non-random component. These have shown a very different approach to unification. And if you believe these, there has to be a very different cosmology than the Big Bang. And if you advocate any of these, it's like all these bricks come down on you. It's like any one of these people, they publish 1 or 2 publications, and there's like 20 saying, no, can't be possible. And you end up wasting time reading them, and then you realize there is no argument against it. This is what, it's a very plausible model for the magnetic field of large bodies. Now what I'm saying is that this is the origin of spin and the origin of magnetism. Then if you have 3 bodies, one rotating about the other, you're going to have a 3-body force. It's weak. It would be hard to measure, but it's there. And it would be an oscillating torsion. Which, if you spend the time looking at all of these Allais observations, the eclipse observations, the ones that go back before Allais, Verdun and Yarkovsky. You see, what really is showing up is an anomalous torsion in space, like space is twisting a little bit. Oh, wrong button. In other words, I'm combining theories that most scientists have never heard of to explain phenomena they don't believe exists. That sums up my life very quickly. Well, yeah, past 30 years. Okay, I'm going to quickly define my version of an ether, spherical rotation, minimum amplitude, principle. And I'm probably just going to go quickly over this. I am trying to come up with an ether that requires the fewest number of assumptions. I'm saying it's continuous and well-behaved. There's nothing smaller. It is everything. And it has some particles are simply waves in this ether. There is no particle or space dichotomy. Particles are treated as the center of waves in an ether. There's no particle-wave dichotomy. Everything is really one. If an element of ether, you take a small part of the ether and you displace it, it will go back to where it was. There is a restoring force. It will not go back instantly, so you could say it has mass. And if you start a motion in it, you will end up creating a wave, and the wave will travel at c in the ether, in the rest frame of the ether, every place. And we can have any type of displacement, longitudinal, translational motion. The ether will always restore back to the original. I'm saying all inertial frames are local, and from that, all physics is local. There is no action at a distance. Now, the assumptions I'm not making here. I'm not saying that if we left the ether alone, it would just sit there. I'm not saying there isn't any large-scale motion in the ether. I'm not saying it's isotropic at any one location. I'm not saying that what appears to be an inertial reference frame right where we are would look as an inertial reference frame someplace else. I'm not saying they're all equivalent. I'm saying there might be a hierarchy. If we were looking at something tiny, its inertial reference frame might be different than us. If we were looking at something big, its inertial frame might be different than us. And I think a lot of this misinterpretation of reference frames has a lot to do with dark matter. I think that's one of the keys. One of the key things we have to look at. Now, Einstein said that matter curves space. I'm saying not quite. I'm saying it's the other way around. If we have a curvature in the ether, it will resist acceleration. If we look at it that way. Curved ether is mass. Mass doesn't curve space. Now, this is a concept that takes a while to digest. It's spherical rotation. There's a nice animation here, and immediately after the conference, I'll send you that old address. We can't get it up there. And I was dependent on that to explain a lot of this. What it is if we take an element of ether and rotate it 180 degrees, and then rotate it at an axis at a right angle to that, we can get a standing wave, a very simple standing wave, probably the simplest soliton that you can come up with, where you have a wave, it's staying in one place, and it's everywhere continuous. There's no breakage of the ether. You can have, a piece of light will come through there, there's no discontinuity or discontinuity, and it will keep going. Now, I actually physically built one of these, and I physically built ensembles of them. This is how far others have got. Both Milo, Wolf, Beatty, Pratt, and Racing have shown that this is a completely classical phenomena which obeys the SU2 covering group. And they also showed that if you assume that the mass is proportional to the second rotation rate, the continuous rotation rate, that this is completely compatible with the Lorentz interpretation of relativity. And they also showed that this is the two waves you get out of there. This is the basic wave. It's compatible with the Compton wave. And if it's moving, what you would see would be the de Broglie wave. It's what you have there is the basis for a completely classical theory of everything. I cannot see, it's like, why hasn't this gotten more attention? It's like, after you've been in physics departments for 45 years, you start to see why. It's that kind of intuition I built up completely, very quickly. But as far as, intellectually, I thought, this would have a path beaten to its door. Ever since Wolf introduced me to Beatty, Pratt, Racing's papers, I gave up all the models I was working on and tried to develop theirs. What I am trying to do is to look what happens when you combine ensembles of these particles together. You end up, mostly the bulk of the wave cancellation, standing waves and things like that, have analogies in electricity, magnetism, and gravity. But there's all these little things left over. Now, Wolf introduced what he calls the minimum amplitude principle. It's something you can observe in waves in a medium, waves in a fluid. If something is oscillating, some kind of periodic motion, the position of the centers of that oscillation will adjust themselves to minimize the total amplitude. It's a classical phenomenon. And the waves in the motion of the plane of the final rotation are analogous to the electrostatic force. The ones coming from the poles are analogous to the magnetic force. And it would probably take me half an hour to explain that. So I'm just going to go to what happens when you start looking at ensembles of these. In most of the drawings, you see a spherical rotation these little filaments that go out and look like axes. They always draw them as they're anchored in infinity, but they aren't. There is no infinity, there's nothing anchored out there. They're anchored in other particles. It's all local. And you can get all kinds of different standing waves with these models. They also produce a three-body force, a weak three-body force, which I think is misinterpreted at various different scales. And somewhere I'm going to get a very crudely drawn I don't have a lot of nice software. Anyway, let's just look at one of these filaments that comes out of one spherically rotating particle, is anchored in another one. One that comes out of that is anchored in the third. If they're all rotating at the same speed, these things will flip from this position to that position without ever crossing lines. You could have spinning, a piece of space spinning continuously, and have it continue, and have it everywhere continuous. Now, if we just look at this, there's also some other mechanisms here. Like, let's say this is happening, and they're rotating at different speeds. If you want to minimize the amplitude of all the waves, you would have an exchange of spin from the fast one to the slow one. It would reach an equilibrium.
Can they be at a much larger distance or? Just
Oh, no. This just keeps going. I mean, I'm trying to, I'm giving you the Cliff Notes version. Now, if we have three particles, the same three particles, but I'm going to have one rotating about the other. We have two types of rotation. The particles are spinning, and one particle is rotating about another particle. That particle is going to either gain or lose one rotation relative to the other ones, every revolution. If they are all spinning in the same direction and the rotation is the same as the direction of spin, it's going to gain one revolution. Like the Earth rotates 23 and some hours in sidereal space, but 24 hours related to the sun. It's that kind of phenomenon. Now, in order to maintain continuity, you would end up introducing a twisting as it does that. Now, if particle motion is random, this is going to cancel out very quickly. You're not going to see it. If you get a bunch of particles aligned in the same direction, you will get some type of twisting of space. And I think I have another crude drawing here. You see, as this goes around, like half, it will go around, this is going to go around one rotation relative to this one, well, half a rotation relative to that one, a quarter relative to this one. So you end up with these filaments not quite being in phase. You're going to end up getting a torsion which is proportion between the three bodies. At most scales, this cancels out. If you look at it on the scale of the Sun, Moon, and Earth, you would get a slight torsion which is consistent with the General Allais Effect. And I was going to explain the General Allais Effect, but I already did that, if you were here. The mass, angular momentum, and magnetic dipole. I don't know if you've seen, how familiar you are with this phenomenon, but this was done by either Wesson or Broche. And what they showed is that if you plot the mass of an astronomical body and the angular momentum of an astronomical body, you get the angular momentum is proportional to the mass squared. And they did some clever things deriving the fine structure constant from the slope of that line. Okay, Sarah plotted the angular momentum of an astronomical body versus the magnetic dipole and got a fairly simple relationship there, which is compatible, is that if the angular momentum is due to the non-random alignment of elementary particles, that is exactly the magnetic field you should see. I guess I don't have to say what's happened to everybody's career when they've published this. Quick, conclusion. If the magnetic field and angular momentum are due to non-randomness of elementary particles, and we have the Beatty-Pratt-Racey model of particles, then we would have a mechanism for the General Allais Effect. We also have a mechanism for flipping of poles. I think, but somebody, Stothers pointed this out, was that if you take a spectral analysis of pole flipping, the main period for poles to flip, Earth's magnetic pole to flip, comes out very close to the period it takes our solar system to make one complete rotation about the galaxy. So you see, that would be the biggest General Allais Effect you would have. You have the center of mass of the universe, the center of mass of the galaxy. We go around the galaxy once, the poles flip. This is the point where you're supposed to burst out in applause. You can't take yourself serious when you say something like this. Anyway, we're going to go right. If you have questions, grab me by the coat and ask them. There